Let us start with today's class with pressure cables. The pressure cables actually it is nothing but a supertension cables. The first one is under pressure cables we study oil filled cables. You can look at the diagram. In case of oil filled cables, the channels or ducts are provided within or adjacent to the cores through which oil under pressure is circulated. The figure here shows the construction of single core oil filled cable. It consists of concentric stranded conductor but built around a hollow cylindrical steel spiral core. This hollow core acts as a channel for the oil. The oil channel is filled in a factory and the pressure is maintained in the oil by connecting the oil channel to the tanks which are placed at the suitable distance along the path of the cable. The oil pressure compresses the paper insulation, eliminating the possibility of formation of voids. When cable is heated, the oil expands, but expanded oil is collected in the tank. While when cable is cooled, extra oil is supplied by the tank to maintain the oil pressure. In this type of cable, the oil channel is within the conductor, hence it is called single core conductor channel oil filled cables. The other construction of the cable is similar to that of solid type cables. Another type of another type of single core coil filled cable is the sheath channel oil filled cable. In this type, the conductor is solid with a paper insulation, while the oil ducts are, you can see here, when the oil ducts are provided between the dielectric and the lead sheath. The construction of sheath channel oil filled cable I have shown in the diagram here. The laying of such cables must be done very carefully. The three core oil filled cables use the shielded type construction. The oil channels are located in the spaces which are normally occupied by the filler material. The three oil channels are of for perforated metal ribbon tubing. All the channels are at arc potential. The construction is, you are seeing the diagram how it is. As the pressure tanks are required all along the route of these cables, the length of these cables are limited. Leakage of oil is another serious problem associated with these cables. Automatic signaling units are located to indicate the falling oil pressure in any of the phases. There are so many advantages and disadvantages of this. Advantages are the thickness of insulation required is less, hence smaller in size and weight. The thermal resistance is less, hence current carrying capacity is more. The possibility of voids is completely eliminated. The allowable temperature range is more than solid type cables. Reduced possibility of earth fault. This is because in case of any defect in lead sheath, oil leakage starts, which can be noticed before earth fault occurs. Perfect impregnation is possible with this. These are the few advantages. Let us come to the disadvantages. The initial cost is very high. Long lengths are not at all possible. The oil leakage is a serious problem, hence automatic signaling equipment is very much necessary. The laying of cable is difficult and must be done very carefully. Maintenance of the cable is also complicated. You are seeing one of the cable here, gas pressure cables. In case of gas pressure cables, an inert gas like nitrogen at high pressure is introduced. Lead sheath. Here you are looking at the diagram. The pressure is about 12 to 15 atmospheres. Due to such high pressure, there is radial compression, due to which the ionization is totally eliminated. The working power factors of such cables is very, very high. In the figure, you can see the section of gas pressure cable here. You can see this is This is gas pressure cables. The cable is triangular in shape. You are looking at that, and installed in the steel pipe. The pipe is filled with the nitrogen at 12 to 15 atmospheric pressure. The remaining construction is similar to that of solid type cable, but the thickness of lead sheath is 75% of that of solid type cable. There is no bedding and serving. The pressure cable was firstly designed by Hofstadter, Vogel, and Bowden. The triangular shaped lead sheath acts as a pressure membrane. The shape reduces weight and produces the low thermal resistance. The high pressure creates the radial compression to close any voids. The steel pipe is coated with a paint to avoid corrosion. During heating, the cable compound expands and a sheath which acts as a membrane becomes circular in such a case. When cable cools down, the gas pressure acting via sheath forces compound to come back to the non-circular normal shape. Due to good thermal characteristics, fire quenching property and high dielectric strength, the gas SF6 is also used in such cables. This is about gas pressure cable.